Good morning. I hope you're all doing well. I am going to go over the solutions to our most recent quiz, Angles of Elevation and Depression. You can feel free to open it on Haiku and we can do this together. I don't have a copy of it printed out, so I am just going to read them off my computer and do them here. Number 1. At a point on the ground 50 feet in front of a tree. So here's the point on the ground. Okay, so from that point, the angle of elevation to the top of the tree, here's that elevation angle, is 48 degrees. Find the height of the tree. So we're always going to refer to our SOHCAHTOA when we do right triangle problems. So from this angle, this is my opposite side, and this one is my tangent of our angle 48 is equal to opposite over adjacent. And that answer is C. Number 2. Johnny is looking out a window and he sees a chipmunk at an angle of depression of 60 degrees. Okay, so Johnny is up here. Here's Johnny. And he is up here. He is in a window. And he is looking outside. Maybe I can do this. There's a chipmunk over here. So sight line. Whenever we talk about sight lines and angles of elevation and depression, they come from a horizontal line. So his angle of depression is going to be 60 degrees. Alternate interior angles, here and here, are the same. So that is a 60-degree angle, and that's how we get inside the triangle. The window is 22 feet high. Then how far is the chipmunk? There it is, chipmunk from the building. 60 degrees. This is your opposite side. This is your adjacent side. Once again, we are using the tangent function. Tangent of 60 is equal to 22 over x. Tan 60, 22 over x. That answer is B. Number 3. Which equation would best solve this? So up looking at is 73. Alternate interior angles puts a 73-degree angle down here. This is our adjacent side. Once again, we're talking tangent. Tangent of our angle is equal to opposite over adjacent. And that would be tangent, so that's C. Number 4. Oh, Janie is snorkeling. This problem on a worksheet, I just gave her a name. This is one of the last ones that we did before we had to break. So here's Janie. Janie is up here and she's snorkeling and all is well and good. Okay, so she is up here snorkeling on the surface and she sees a turtle down here on the ocean floor. So there's our turtle. Here is Jane. Now Jane's 40-degree angle, alternate interior angle, puts our 40-degree angle here inside our triangle. Height is always measured perpendicularly, and she is 14 feet above the ocean floor, so there's our 14. How far is the turtle from Jane? So we want to know this distance here, that's our x. So 40 degrees is here. That is your opposite side, and this is our hypotenuse. Opposite and hypotenuse. Our angle is equal to 14 over x. Oh, the only one with sign is A, so that answer has to be A. Moving on to number 5. Oh, a lot of room. Let's see if I can get this to come. No, you know what? I'm just going to slide my board over here. So here's number 5. Plane takes off and flies in a straight line for a distance of 4,000 feet. Here's my question for you. If a plane flies in a straight line, all lines are straight. If a plane flies in a straight line and gains an altitude of 800 feet, is that plane rolling on the ground here? Or is that plane flying through the air here to reach that point 800 feet high? That is where the 4,000 goes, because that is the flight path of our plane, and it has traveled this distance of 4,000 feet in order to gain a height of 800 feet. We want to find this angle of elevation. There's your x. According to this angle, that's your opposite side. Here's our hypotenuse. Once again, we're going with sine. Sine of x is equal to opposite over hypotenuse, which is 4,000. And in number 5, the only problem that uses sine is B. Number 6. Let's keep going. Number 6. So now we have a ladder. It's leaning against a wall. Looks like this. Okay. Ladder against the wall. The foot of the ladder is 6.65 feet from the wall. 6.5 feet from the wall. And it makes an angle of elevation, oh, there it is, 74 degrees. How high on the wall does the ladder reach? Opposite, adjacent, tangent. Tangent of, let me see, oh, there's 2.7. A picture for it, I get it. There was a lot going on here. Here's your basic picture. From the top of a roller coaster, that's here, 60 yards. I'm sorry about I wrote my answer in feet. Doesn't matter. Most of us didn't notice that. Let's see. A rider looks down and sees the merry-go-round and the Ferris wheel. The angle of depression is 8 degrees to the Ferris wheel. Okay. Although we see two things, we are only talking about that 8 degrees the Ferris wheel. It's the only number mentioned that I typed out in the word problem. I get that there are two, but we do not care so much about the merry-go-round. Question is, how far is the rider from the Ferris wheel? Okay, we could have interpreted this two different ways. I accepted both answers. Maybe some of us went perpendicular distance. Maybe some of us were going Y down here to the entrance, and I accepted both of those. If you went with 8, then that's going to be tangent. And then you kind of probably use the equation tangent of 8 is equal to 60 opposite over adjacent. If you thought maybe you were finding this distance to the entrance, 60 over Y. Either of these is fine. One of the answers, what do I have for the answers? One of them is like 426.9 and the other is 431 something. So both of those answers were accepted for number 7. Moving, it's the top of an 84-foot tall lighthouse. Okay, here's Andrew, and there's the 84-foot tall lighthouse. This, by the way, was another problem from the worksheet. He's feet tall. Okay, so now when he looks, he is already going to be 6 feet high because his eyes are not on his toes. So he is looking here. He is 6 feet tall, which means that we are going to the top of the lighthouse, which means that we are going to be using 78 feet as our lighthouse for our equation, just like on the worksheet, number 1 on the worksheet. Let's see. I lost my place. Oh, Andrew's 6 feet tall. Then how far is he standing from the base of the lighthouse? So we want to know this. By the way, this is a rectangle, so there's our x there, perpendicular. So what we want to do is say, okay, so now that we're at our 78, 48 degrees. That's what I was missing. 48 degrees, angle of elevation. So opposite, adjacent, tangent of 48 degrees is equal to 78 over 2, 70.2. I don't know why I wrote 5. 70.2. What I would do in my calculator for this one is I would switch these places and I would do 78 divided by tan 48. And let me get it so you can see. There it is. Okay. 70.2. All right, 2 more. I'm in for it. Okay. Let's see. We have a 20-foot ladder, number 9. Where can I go? All right, here's number 9. So I have a 20-foot ladder, 72 degrees. Find the distance between the foot of the ladder and the building. There's x. So for this, we have an adjacent side and we have the hypotenuse. So we are using cosine. Cosine of 72 is equal to adjacent over 20. Cross multiply, 20 times cosine of 72, 6, we round. Okay, last one, number 10. From Rapunzel's Tower. Oh, this one's from a worksheet too. I just made it all princessy because, it's more fun that way. Rapunzel's Tower, the angle of depression to her prince. Okay, so Rapunzel is up here in her tower. There's Rapunzel. This is her sight line. Here's her prince. Her prince is down here. And the angle of depression is 72 degrees. Alternate interior angles, there is 72. Top of the tower. This is a whole bunch of tangent going on here. So this is your opposite side, your adjacent side. So tan of 72 is equal to 80 over x. Cross multiply, it will just be 872 because we can swap places. Let me do that. 80 divided by tan 72. There it is, 0.99. All of that is going to just round to 26. So that answer, just like it was in the worksheet. Hope you guys learned something. Questions, please come and ask me. Have a great day.